space between the pencil and the needle. You measure it, you make it 4 centimeters. Okay. And then you draw a circle with keeping this point as constant, and you draw a circle. So that circle will be congruent to this circle. Yes or no?
Yes.
Okay. So for a circle, if you want to make a copy of a circle, what all measurements do you need? Once again?
Like,
yes?
The compass.
No, what all measurements do you need? Not the tool. This is a tool.
Okay.
What all measurements do you need?
4 centimeters.
Yeah, just the radius. Yes. So remember this, for a circle, to make a circle, you need just the radius. Okay, and you will be able to make the circle. But okay, now let's say for a square, if I give you a square, if I give you this square, okay, and I say that its side is 5 centimeters. How will you make a congruent square?
I will just measure 5 centimeters on my scale and then draw a whole square.
Yeah. So first what you will do is, first you will draw one line segment of 5 centimeters, then you'll draw another at 90 degrees, right? Another line segment 5 centimeters, then another one. Okay, so you will measure from here to here. This should also be 5. From here to here, this should also be 5, right? And then from here to here, you will join these two, and then you will measure this just to check how much it is. And it will be 5 centimeters. Okay, so then you have made a congruent square. So what measurement did you need? You needed only one measurement again, that is one side, because all the sides are the same. Yes?
Yeah.
But in a rectangle, if I give you a rectangle and I tell you that Hiba, one of the sides of the
Can we have a class for 1.5 hours, because I have exam tomorrow?
You have exam tomorrow?
Yeah.
Okay, but say you should have told me that before. Actually, I
already studied. I just have to learn this one chapter.
Okay, I understand. But it would have been better if you could have told me this before, because I had to arrange the meeting ID. Okay, so no problem. It's okay. We'll have only for 1.5 hours today. All right, no problem. So, Hiba, now tell me, let's come back to the rectangle. Okay.
Okay.
Now let's say that I say that Hiba, I'll give you, you have to make a rectangle the same as mine, and the rectangle has 5 centimeter, one of its sides is 5 centimeters. Will you be able to make an exact rectangle?
No.
No. Why not?
Because we only have the measure of one side and not the other side.
How many more measures do you need?
One more.
One more, exactly. So if I tell you that one side is 5 centimeters and the other side is 7 centimeters, will you be able to make the rectangle?
Yeah.
Yes, because then you will say that this is 5, so this will also be 5, the opposite side. And then the length is 7, so the opposite side will also be 7. So you will be able to make the exact same rectangle as I have made. Okay. Okay. Now let's come to triangles. If I say that Hiba, make a triangle which has one side is 4 centimeters. Okay. Will you be able to make a triangle just as I am imagining?
No.
No. What else do you need?
Two more measures.
2 more measures. Very good. Okay. What if I tell you that Hiba, it is actually an equilateral triangle?
So all the sides will be 4 centimeters.
Very good. Exactly. Okay. Now, what if I tell you that it's not an equilateral triangle? I'm giving you a different triangle. It is a right-angled triangle. Okay. One side is 4 centimeters. Do you think you will be able to find out?
No, we need one more measure.
We need one more measure. Which measure do we need?
The hypotenuse.
Very good. And how do you know this?
I just thought that was the answer.
Sorry?
I just thought that was the answer.
Oh, wow. That's really great, mashallah. Okay. So just remember what you said here, okay? When I tell you that this is a right angled triangle, okay? So this is, you have one R, which is R stands for right angle.
Right
Okay.
angle triangle.
You need the hypotenuse H and you need one side. You don't need all three sides. You just need the hypotenuse and one side. Okay. In this case, we have 4 centimeters and R is the right angle. All right. So this is called the RHS congruence criteria.
But I have a doubt.
Yes.
Can you draw a right angle triangle?
Okay. Yeah, there you go.
Okay, so if one of the side is 4 centimeter, then we have to find the measure of two sides, right?
Measure of?
Two sides, like the hypotenuse and the base.
Do we have to? Do we really have to? Or will it just be fine if we have just one angle, which we know that it is right angle, and the other hypotenuse also we know? Let's say I tell you that the hypotenuse is 5 centimeters, for example. Then will you be able to make this triangle?
Yeah, like
let's see how. Okay, let's see how that will be possible. I'll tell you. See, so what we'll do is we will take Hiba, first tell me this. So Hiba, you know what we do, and actually you're not going to be studying this in 7th grade. You'll be studying this later on, how to construct a triangle. When given some measurements are given to you, how do you construct a triangle? That will be given to you in a different later class. But I'm just showing this to you to help you understand the concept. Okay, so what we do is we make a rough sketch. Okay, a rough sketch. What we do now is that whatever information has been given to me, I write it down. I mark this as 5 centimeters. Okay, that's given. 4 centimeters, that's given. So for whatever is given to me, no, like over here, what I did was the unknown side, this side I don't know. So this side I should not make the base, because over here we are going to measure this side. Okay, so we're not going to make this as the base. So the base, this one, the horizontal one, I have made that side which we already know. So that is 4 centimeters. Okay, so we know two things, actually two sides we know, and the third one is a right angle. So now what we can do is, first of all, we will use our scale. We will measure 4 centimeters. Done? Okay. We'll do this. We will write 4 centimeters over here. Now, we will take, let me use some other color. We will draw a 90 degrees line. Now, we don't know how long this is going to be, right? So we will just draw a 90 degrees line like this. We don't know how long it's going to be because we don't know this side. So we don't know whether the triangle will look like this or it will look like this. We don't know. So we'll just draw a long line like this. Not line segment. Fine.
Okay.
Now what we'll do is we will try to make from here to here. We will see, is this much 5 centimeters? Or is this much 5 centimeters? How much is 5 centimeters? How do you think we will find that out? Or is this much 5 centimeters? How will we find it?
The purple one.
Sorry?
The purple one. is 5 centimeters.
How do you know? You haven't measured it, na?
We can just measure and then tell.
Okay, so they are just 3. I've just drawn 3 for example. You can draw so many. How about, what if the 5 centimeter is over here? What if this is 5.5 centimeters and this is 4.8 centimeters, the purple one? Then what will you do? Will you sit and measure each and every single point? You can't do that. So you know what we do for in such a situation? We take a compass. Okay, you take a ruler, your scale. Okay, here it is 0, 1, 2, 3, 4, 5. This is 5 centimeters, right? Then you take your compass, you put the needle at 0, and you take your pencil, the pencil part of it, and you put it at 5. So now this length is going to be 5 centimeters. Now you don't change the length of this compass. Okay, now you put the needle over here, and your compass is going to look like this. You put the needle over here and your pencil over here. Okay, now this is 5 centimeters from here to here. So you will know that, okay, this one is 5 centimeters. I'm not going to go into the details because then this is not a part of your syllabus right now. So we'll just be wasting time if I go into further details. So the point over here is we will be able to make the 5 centimeters over here. Okay.
Okay.
So now this part is your triangle. And to make this triangle, you needed only 3 things. What were the 3 things? The right angle, the hypotenuse, and the side. So this is called the RHS congruence criteria. So similarly, there are many congruence criteria. Just like the first thing that you said when I asked, Hiba, if you have to make a triangle, how many measurements will you need? You said we will need 3 sides. Remember?
Yeah.
Remember, Hiba?
Yeah.
Yeah. So in some triangles, if you have 3 sides, that's called the SSS, which means side, side, side. Congruence criteria. What does this mean? This means that if I give you a triangle, I say, Hiba, draw me a triangle. I am imagining a particular triangle, or maybe I have made it over here in my notebook, and you have to make a copy of this triangle, okay? One which is exactly like this in your notebook. So I have to give you at least 3 measurements. Okay, those 3 measurements, if I give you, okay, one side should be 6 centimeters, one side should be 5 centimeters, and one side should be 4 centimeters. Okay, not 4, it won't be 4. One sec. 4 centimeters.
Wait,
okay.
Can you explain it again?
Which part,
like
Hiba?
The SSS.
Yeah, that's what I'm explaining. See. Okay. The first thing which I asked you, first we talked about circle. How many measurements do you need for a circle? 1. How many measurements do you need for a square? 1. How many measurements do you need for a rectangle? 2. How many measurements do you need for a triangle? What did you say?
3.
3. Very good. So if I give you 3 sides, if I say that, Hiba, I have drawn a triangle in my notebook and it has the 3 sides of this triangle are 6 centimeters, 5 centimeters, and 4 centimeters. Will you be able to draw the triangle?
Yes.
Yes, exactly. So similarly, so this is, I have given you, what all 3 things have I given you? I have given you 3 sides. So this is called the side congruence criteria, which is SSS, congruence criteria.
Criteria means equal.
No, criteria means, so criterion is singular and the plural word is criteria. Okay. Criterion means the condition for something. Criterion basically means condition. Condition in the sense, for example, Hiba, I tell you that let's say I say that Hiba, you have a particular rectangle and it will be a square. Your rectangle can be a square only under the condition that its length is equal to the breadth. Got it?
Can you explain again?
Okay. See, you are understanding what condition means, right? Criterion means condition. Like, what is the condition for two triangles to be congruent? That's why we say congruence criterion.
Okay.
What is the condition for two triangles to be congruent or two triangles to be the exact copies of each other? So one of them is the, got it?
Yeah.
Yeah. One of them is the SSS congruence criterion. The other one is, as you said, RHS congruence criterion. And another one you have. Yes,
I didn't understand the RHS.
You were the one who told RHS, remember? I told you that RHS means you have one side, you have one hypotenuse, and you have a right angle. That means RHS, right hypotenuse side. This is the congruence criterion. We will see this as we go further. Okay. Okay. Let me give you two triangles. Wait a minute. Okay, got it. So this is a rectangle I'm drawing. Okay. This is a rectangle and I'm telling you that, one sec, this over here, this is the diagonal. Yes.
Okay.
Okay. Yes. So we know that one side, this side is equal to this side. Okay. And this is a right angle. Yes. And this is a right angle. So we have two triangles over here. Can you see the two triangles?
Yeah.
One is this triangle, the yellow one. Let's call it triangle AB. Wait, triangle ABD. What is the name of the yellow triangle?
ABD.
Okay, then we have this green triangle. What is the name of this green triangle?
BDC.
BDC, very good. Which two triangles do you think will be congruent over here?
Angle ABD.
Triangle.
Triangle ABD and triangle BDC.
Okay. ABD and not BDC. You have to say BCD. In fact, not BCD. You have to say, okay, I'll tell you how. See, triangle BDC is the same as triangle BCD and that's the same as triangle CBD. It's the same thing. But we order the letters carefully when we are talking about congruence. You know why? Because, Hiba, tell me which part of the yellow triangle is corresponding to which part of the green triangle. Okay. Which part of the, or let's say which part of the green triangle is corresponding to A? Point A, vertex A.
C.
Very good. So with C, with A, what is corresponding? C is corresponding. So when you say ABD, then the first letter in the other triangle should be C. Okay. And now,
CBD.
no, one sec. Let me just tell you why not CBD. Okay. Look at the side AB. Which side in the green triangle is corresponding to AB?
DC.
CD. Yes, because A is corresponding to C. So when you say AB,
Okay.
got it? When you say AB,
But
you have to say
but
CD.
but DC is the same as CD.
Yeah, exactly. That's what I told you. That they are the same. They are the same. But we say it like that because, see, it's the same. Okay. It's not going to make a difference in the answer. But the reason we say it is for our own convenience. So that when you look at those two triangles, you immediately know which two sides are corresponding. So if you write this, let me just give you an example. If you write this as AB is corresponding to DC, then you will write this as this triangle. You will write it triangle ABD is congruent to triangle AB is corresponding to what? DC, na? So DC,
Yeah.
and whatever B. Okay. Now there will be a problem here because your angle A is 90 degrees. So according to what you have written, angle A is corresponding to, according to what you have written.
C.
No, according to what we have written here. What is the first letter in this one?
A.
What is the first letter in this one?
D.
D. Right? So angle A we are saying is corresponding to D, which is not true. Angle A is corresponding to angle C, yes?
Yeah.
So that is why we have to be very careful about the way, or the order in which we are writing it. Is that okay?
Yeah.
Okay, all right. Just a sec. All right, so how do we name it? Now, AB, which side is corresponding to AB again? Which side?
CD.
Very good. C, D. We start from C. Why? Because over here we started from A, and A is corresponding to C. Okay.
Okay.
So C, D. And then which side is corresponding to the other one? The last one that is remaining is B. Okay. So from here you can clearly tell that AD, look here, AD is equal to CB. AD is equal to CB. It's corresponding to CB. Okay, so this is your RHS congruence criterion, where you had one side over here. You had one side that is equal. Yes.
Yeah.
RHS. One side is equal. Right angle, right angle. Both have a right angle. And both of them, their hypotenuse is the same or different?
Same.
Hypotenuse is the same. So they are congruent by RHS congruence criterion.
Okay, understood.
Very good. By RHS congruence criteria. I'm not going to write the whole thing. I don't have space here. Okay, so one of them is SSS, which is side, side, side. One of them is RHS, which is, can you repeat? What is RHS?
Right angle triangle, hypotenuse, and side.
Yes, the short form is right hypotenuse side. Can you repeat?
Right hypotenuse side.
And what is SSS?
Side, side, side.
Very good. All right. All right. So so apart from these, there's one more, which is not one more, there are a few more. One of them is SAS congruence criteria. What does that mean? You don't have three sides in this case. Okay, you don't have three sides. You have two sides
And one angle.
and one included angle. That means if you have this side and this side, then the angle between them, which is this one. Okay, not this angle or this angle. No, the angle between them. So when you say SAS, you go like this. SAS. Got it?
Yeah.
Very good. Let's first do try these on page number. What's the page number? 140.
Okay. Okay.
Okay, have you opened the page?
Yes.
Okay, can you read the question, Hiba? And while you read it, please try to understand it as you read it. Okay.
Okay. Lengths of the sides of the triangle are indicated by applying the SSS congruence rule. State which pairs of triangles are congruent. In case of congruent triangles, write the result in symbolic form.
Very good. Okay. So let's try question number 1. Look at these two triangles. What are the names of the two triangles?
ABC, and triangle ABC and triangle PQR.
Very good. Can you look at these two triangles and tell me whether they are congruent?
Yes.
So what will we write? We will write triangle ABC is congruent to triangles.
PQR.
Very good. Okay, so we don't have to do anything else in the question, right? Write the result in symbolic form. Okay, so we have written it. Let's come to the second part.
They are not congruent.
They are not congruent. What are the three sides, Hiba?
Oh, they are congruent.
What are the three sides? Which congruence criterion are we using? We are using SSS. Remember that. So we have to look for three equal sides. That's it.
Okay.
So
it doesn't matter where the numbers are. It just has to be equal, right?
Yes, when it comes to SSS. Okay. Are the three sides equal?
Yes.
Very good. Okay, so again, now here is what is important. Which two sides are equal? DE. Let's first look at DE. Okay. DE is equal to which side?
MN.
Very good. MN. All right. Can we write this as NM?
Yes.
First N and then M. You know why? Because let me try. So over here E is the right angle, right?
Yeah.
And over here M is the right angle. So that's why I am writing it as NM. So that E and M, they are both right angles. So they will correspond to each other. Getting it?
Yes.
Good. Oops, mistake. Yeah. So DE is equal to NM. Next, can you tell me which two other sides are equal?
EF.
Very good.
LM.
EF and
ML.
Very good. ML. Yes?
Yes. And
Next.
then FD and NL.
FD and which one first?
NL.
NL. Okay, let's see about this. see, what is corresponding to F?
N.
L. Yes. So
How?
see here. When you are writing EF is equal to ML, let me one sec. What is below F?
L.
L. Yes. So what is corresponding to F?
L.
L. So shall we write it like L below F and then N? Okay. Because over here, as you can see, D is corresponding to N. Yes.
Yes.
D is corresponding to N. Got it?
Yeah, but why can't we write LN? No, why can't we write NL?
See, you can write that. That won't be a problem. But when you are writing this triangle is congruent to this triangle, you will have a little bit of a problem. You won't be able to. Let me just show you. Okay. Let's say
if I write NL, will it change my answer?
It won't change your answer, bacha, but it will give you some problem. Let me show you how. Now, Hiba, you have seen this side is equal to this side, this is equal to this, and this is equal to this. Now tell me how will you write it in symbolic form? Which two triangles are congruent to each other? And remember, over here, order matters. When you are writing so and so triangle is congruent to so and so triangle, the order matters. Why? Because if I say, let's say I have a triangle ABC like this, okay? And I have another triangle DEF. Then I cannot change the order according to my own wishes. I can't say that triangle ABC is congruent to triangle FDE. Can I say this?
No.
No. AB is
DE.
superimposing on DE.
DE.
So in front of AB, I should write DE. Over here, it should be DE, not FD. So it should be D, E, and then F. It should be like this. So the order matters when you are writing this particular statement. Over here, the order matters. Over here, whatever you write, your marks won't be deducted. But over here, yes, they will be. Getting it?
Yeah. Yes, I understand.
Right. So the reason why we write it over here also, we take care of the order is so that it becomes easy for us to write this statement in order. Got it?
Okay.
Yes?
Yes, I understood.
Okay.
I understood.
All right, good. So over here, FD is equal to what will we write? LN. Okay. Now, can you tell me how do we write this statement? Triangle for the second part.
Can you repeat the question again?
How do we write this statement? Triangle, which triangle is congruent to which triangle? For the second part of the question, the one that we're just doing, this one.
Angle.
Triangle.
The triangle DEF is congruent to. No, sorry.
Yes, DEF. Then the second one, you have to be a little careful. Yes.
Okay, it is congruent to M N L M.
Okay.
No.
D. Bacha, which side is corresponding to D? Which vertex is corresponding to D?
L.
See here, look at this, what we have written here.
Sorry, N.
N. And so D, N. And what is corresponding to EF?
ML.
ML, very good. So triangle NML. Do you see it now?
Yeah.
Okay, so basically what will happen is you will rotate that triangle a little bit. So it will look like this.
Why didn't we do FD?
Let me show you. The triangle on the right, triangle NML, okay? Rotate it like this and it will be like this, okay? And your other triangle, which is DEF, looks like this. Now tell triangle NML. Yes?
Yes.
This and this, they both are congruent.
Okay,
See,
understood.
3.5, 3.5. This one, DE is equal to NM. Over here also we wrote DE is equal to NM. 3.2, 3.2. EF is equal to what? ML. ML. 3 is equal to 3. Are you understanding this now?
Yes.
Good. So the next one you will be telling me how will we?
Can you go back to the 7th page? Can I write this down?
Yeah.
Okay, we can continue.
Okay. Third part, Hiba.
They are not congruent.
There's no third part in your book?
No, they are not congruent. The third question.
Acha, okay. They are not congruent. Why?
Because in triangle ABC, the measures are 2 centimeter, 5 centimeter, and 4 centimeter. But in PQR, it is 2.5.
Very good. So even though AC and BC, they have corresponding sides, but AB, which is 2 centimeters, that doesn't have a similar side, corresponding side in the other one, right? And the other one is 2.5. Okay. Fourth part.
They are congruent.
Why?
Because it is like there are 2 triangles in that, and it's confusing.
You told the answer, no? Okay. First, tell me which triangle is congruent to which triangle?
AB is congruent to AC.
AB is a side, bacha. AB is equal to AC. Yes?
Okay. ABD is congruent to ADC.
No, ADC.
ACD.
ACD, yes. Triangle ABD is congruent to triangle ACD. And once again, I will tell you why we don't write ADC. Because when you have triangle ABD, which looks like this, and if you try to superimpose triangle ADC on this, that means this is B, this is A, this is C, right? So your D will come over here, your A is like this, and your C is like this. It's not superimposing. If you try to fix the D point on top of the B point, because you're saying ABD and what you said was ADC. Yes?
Yes.
But B and D, they are not corresponding sides. What is the corresponding, vertices? What is the corresponding vertex for B? Look at the diagram.
B, it is C.
Very good. So that is why we write ACD and not ADC. Got it?
Okay.
Because AB is equal to AC. And obviously AD and AD are the same in both the triangles. Yes?
Yes.
And then the third side is BD is equal to CD, not DC. You won't say DC, you will say CD. Got it?
Okay.
Okay.
How is AD equal to AD?
AD is not equal to AD. Hiba, what is 5 is equal to 5? 4 is equal to 4? Any number is equal to itself?
Yes.
That is why.
Okay. Can
Got
you
it?
give me
Yeah.
1 minute right now?
Hmm.
Okay, we can continue.
All right. Next, the second question.
Okay, in figure 7.15, AB is
7.15.
7.15. AB is equal to AC and D is the midpoint of BC.
Okay, one sec. This is the figure. What are they saying? AB, first let me write it. A, B, C, and D. AB is equal to AC. So this is equal to this. Fine.
Yeah.
And D is the midpoint of BC. Midpoint means this side
Median,
is equal to this side.
this side.
So over here in these two triangles, are they congruent or not?
They are
They are. Why?
because it is triangle ABD and triangle ACD.
Very good. So we write it like this. Okay, Ba? In triangle ABD and I don't have enough space here. Wait. Yeah. In triangle ABD and triangle ACD. Now what is equal to what?
AB is equal to AC.
AC. Very good. Then
AC.
BD is equal to
DC.
DC.
CD.
CD. Very good. Very good. Next.
And then AD is equal to AD.
AD is equal to AD. So therefore, then we put these three dots. These three dots, they stand for therefore. Therefore means so. In maths, we write therefore like this. Okay.
Okay.
It means so, or you can say thus, or you can say hence. All right. Therefore, triangle ABD is congruent to triangle ACD. Got it?
Okay.
Now they're asking, is angle B equal to angle C? Why? In the third part of the question, we have done the first two parts.
How did we do the second one?
Okay, now you tell me the answer of the second one.
They are congruent because of the
They
first
are
answer.
congruent. Because?
Because of the first answer.
Very good. Because of this first answer, which we've written over here. Okay. Okay. So, third question. Is angle B equal to angle C?
Yes.
Why?
Because they are equal.
Because yes, so you write it, we say that they are both corresponding parts, right?
Basically, BD plus CD is BC.
Yeah, that is the sides. We are talking about the angles. So see Hiba, in these two triangles, the left and the right triangle, these two angles are corresponding angles, right? Corresponding angles, not in this sense, not that they are two parallel lines and transversal. No, we're not talking about this corresponding angles. We are talking about corresponding angles. Like remember we said corresponding vertices, corresponding sides, corresponding angles. Remember?
Yes.
So these are the all of these vertices, sides, angles, they are called corresponding parts. Okay. So we say corresponding parts of two congruent triangles, right? The two triangles are what? Congruent. Yes.
Yes.
Corresponding parts of congruent triangles are equal. Yes, that's why angle B is equal to angle C. Yes.
Can you explain again?
Which part did you not understand?
Like corresponding parts of congruent triangles are equal.
Okay. Let's break down this particular statement into three parts: corresponding parts, then congruent triangles, then equal. Fine. What is the meaning of corresponding parts, Hiba?
They are equal.
Now, what is the meaning of corresponding parts? If I say that these two triangles are congruent, then what all are the corresponding parts?
ABD and ACD.
No, though triangle ABD and triangle ACD are triangles. I am talking about parts of the triangles. Triangles have parts, no? Yes. What all parts do they have? Triangles are made up of sides, they have angles, they have vertices, right? They have three angles, three sides, three vertices. So all of these three things, angles, sides, vertices, they are called parts. So when these two triangles are congruent, what are the corresponding parts?
The vertex.
Okay, what are the corresponding vertices? Okay, let's say this. For what is the corresponding vertex of B in the green triangle? Yes?
C.
C. What is the corresponding angle for angle B? What is the corresponding angle?
Angle C.
Very good. What is the corresponding part for side BD?
CD.
Very good. What is the corresponding part for side AD?
AD.
AD, very good. What is the corresponding part for angle ADB?
ADC.
ADC, yes, excellent. Okay. So what are we saying? These are corresponding parts. Yes.
Okay.
B and C, corresponding parts. They're corresponding to each other. So corresponding parts of these two congruent triangles, they are what? Equal. Just now we saw angle B is equal to angle C. Yes.
Yes.
So that is what we mean when we say corresponding parts of congruent triangles. They are both congruent triangles. That is why they have corresponding parts. So corresponding parts of congruent triangles are
equal.
Got it?
Yeah.
Okay. So in short form, we say CPCT. Okay. C P C T. This is the short form. Okay. So if someone asks you, Hiba, why is angle B is equal to angle C? Because corresponding parts of congruent triangles are equal. CPCT.
Okay, can you give me 1 minute to write it down?
Yeah.
Okay, I completed.
All right. Next. Question number 3. Yes, Hiba?
In figure 7.16,
Hmm.
AC is equal to BD
Hmm.
and AD is equal to BC.
Hmm.
Which of the following statements is meaningfully written?
Hmm.
Triangle ABC is corresponding to triangle
Congruent.
congruent to triangle ABD.
Hmm. Or the other one. Which of them is correct? Triangle ABC will be, look at the diagram in the book. Triangle ABC will be congruent to, we will say triangle ABD, or will we say triangle BAD? Look at them very carefully.
Okay.
Are you getting confused because of the diagram?
No.
No? Okay, very good. Let me just draw the diagram just in case, to make things easier. Or one thing that we can do is, okay,
The second one is true.
just a sec. Let me just name them, okay, quickly. C, A, B, and this one is D. This is equal to this. This side, this whole side is equal to this whole side. AC is equal to BD. Okay. So what are you saying? The second one is true. Triangle ABC is congruent to triangle BAD. Very good. And why is the first one not true, Hiba? Why is ABC? Why should we not write it like this? I'm sorry. Triangle ABC is congruent to triangle ABD. Why should we not write it like this?
Because in that question, A is corresponding to A and B is corresponding to B and C is corresponding to D, which can't happen.
So in these two triangles, AB is equal to AB, yeah, of course. But over here, ACE is equal to BD and AD is equal to BC. So that is why we should write it like AB is corresponding to.
I said the second one because A is corresponding to B and B is corresponding to A and C
Very good.
is corresponding to D.
Very good. So over here, we will write it as AB is equal to BA. AB is equal to BA. So we will write it as triangle ABC is congruent to, so AB. So here we write BA. And instead of BC, we have AD, right? So AD. Okay.
Okay.
So now that means you have understood.
Yes.
Okay. Now let's do the example. Okay, no, not example. Okay, fine. Let's come to page number 144. Remember the SAS congruency criteria that I told you?
Yes, a side and side.
Very good. The angle should be included. Included angle means the angle between these two sides. Got it?
Yes. Try these.
Yes. Try these first question. So they are saying triangle DEF. They haven't made any diagram. So you can just make any random triangle and name it DEF. Okay. Now, read the question.
Which angle is included between the sides line segment DE and line segment EF of triangle DEF?
So which two sides are they talking about? DE, this one, and
EF.
EF, this one. So which angle is included between these?
D.
Angle D.
Wait, how is it? How is it EFD? Like
Oh, I'm
the
sorry, Hiba, I'm really sorry. Um, I didn't pay attention to that.
it's okay.
They said EF, right? EF is this one. Now tell. Which angle is included?
E.
Angle E. Okay, what is the expanded name of this angle?
What does it mean?
Remember, we saw there were three ways of naming an angle. One is you just say angle E. Another one is like saying angle ABC. And this middle one is the vertex. Remember?
Yeah.
What is the full name of this? It's like a full
D.
name basically. Yes?
DEF.
Very good. Angle DEF. Okay. Okay, Eba. Second question, please.
Okay, wait a second. Wait, can I draw this figure real quick?
Yeah, sure.
Okay. By applying a side angle side congruence rule, you want to establish that a triangle PQR is congruent to triangle FED. It is given that PQ is equal to FE and RP is equal to DF. What additional information is needed to establish the congruence?
Okay. What does this mean, Hiba? Can you try to explain it to me?
I didn't understand.
Didn't understand. Okay. So if you don't understand a question, just whatever information is given, just first make a rough diagram. Okay.
Okay.
So make a rough diagram. They are saying triangle PQR and triangle FED. So this is PQR. So since it is rough, I am not spending too much time in making it look equal or something. Okay. FED. PQR, FED. You have to write it in that order. So they are both congruent. They are saying that they are both congruent. It is given that PQ is equal to FE. So this is equal to this. RP is equal to DF. RP is this one. DF is this one. So they are both equal. So according to SAS congruence criteria or congruence rule, you can even say rule, you don't have to say criteria every time. Okay. So according to this rule, which one more additional information is needed to establish the congruence? That means what is one thing missing when if you try to
QR is equal to ED.
That is the SSS congruence rule. But we are talking about SAS. Over here, if you want to show it through SAS rule, which angle do you need? Which measurement do you need according to SAS rule? You have two sides, right?
Yeah.
Now what do you need?
Wait a second.
Look at SAS. What does SAS mean?
Side angle side.
So you have two sides. What do you need?
An angle.
Which angle?
Q.
Included angle. What does that mean? The angle that is between the two sides.
How do we know that is between?
You tell me which angle is between these two sides? Between PQ and PR, which is the angle between these two sides?
Can you color them?
Good. Okay. Between, oh, wait. Between PQ and PR, which is the included angle?
P and F.
Very good. So you need these two. Angle P is equal to angle F. Got it?
Yeah.
That's it.
Can I write it down?
Yeah, sure. Also, Hiba, in your math exam, if you are having any difficulty and if you feel like, if it was colored, it would have been easier to understand. Don't worry, feel free to carry colors. Okay. In fact, your teacher will be happy that you've made your answer sheet look colorful.
Okay. I will do that.
I'm just saying that if you need to, then don't hesitate. You can take it. Okay.
Okay, sure. I will read the third question.
Shall we move forward?
Yeah. In figure 7.24, measures of some parts of the triangles are indicated by applying a side angle side congruence rule. State the pairs of congruent triangles, if any. In each case, in each of congruent triangles, write them in symbolic form.
Okay. What they're saying is, it's the same thing. The same question that we had in the SSS thing. Okay. They're giving you two triangles. You have to tell whether or not they are congruent. If they are congruent, you have to write them in symbolic form. Got it?
Okay.
So let's come to the first part of this question. Yes. According to SAS, you have to see.
Yes, they are.
They are.
I don't understand why they have put 80 and 70.
That is why they are not equal. They are not congruent. Getting it? AB. So we need one side. Okay. Side AB is equal to side DE. Check. Fine. Then we need an angle over here. This is the side. Then we need an angle. Then we need a side. So this other side AC is equal to DF. Again, the second side is also done. But the included angle,
they are not equal.
They are not equal. So
the angles have to matter the most.
Sorry?
So the angles matters the most.
No, it is not that what matters the most. See, even if two things are equal and the third thing is not equal, then they won't be congruent.
How do we know that all of them is congruent?
If these three things, all three are equal, if all three are equal, then it is congruent. Even if one of them is unequal, then they are not congruent.
Okay, understood now.
Okay. So let's say if you have, let's say, two triangles like this, this side is equal to this side. Okay. And even this angle is equal to this angle. But this side and this side are different. They are unequal. Even if, let's say, there's a very minor difference. Let's say this is 3 centimeters and this is 3.2 centimeters. They are different. So they are not congruent. Even if this is equal to this is equal to this, but the third thing is not equal, so not congruent. Got it?
Yes.
Good. Now let's come to the second part quickly because we have only 13 minutes left.
The second one, it is congruent to each other.
Very good. Now, which triangle is congruent to which triangle? Remember the order.
Yes. AC is congruent to RP. And
AC is congruent or equal?
Equal, sorry.
RP, very good.
Oh yeah. And QP is equal to BC.
QP I will write over here. I will write it under this one. Okay. All the measurements of the right hand side wala triangle triangle, I will write on the right hand side. So one sec. Before writing, I will leave some space because we have to make it like S, then included angle, then S. Okay. So the third measurement, which is the other side, I will write in bit. I will write in the third line. So what did you say? QP is equal to BC.
BC.
Very good. Then angle.
Wait a minute. And then angle ABC is congruent.
ABC. Angle ABC.
No, triangle.
Ah, which side? You didn't mention the side.
Oh,
I'm sorry, angle. You didn't mention which angles are equal.
PR is equal to CA.
Bacha, PR is a side, na?
Oh, angle. Sorry. 35 degrees is equal
What
to
is the
35.
name of 35 degrees?
P is equal to C, or C is equal to P.
Angle C is equal to angle P. Very good. So now finally, which two triangles are congruent to each other? Name the triangles.
Triangle ACB is
Very good.
congruent to RPQ.
Very good. RPQ. Excellent. All right, let's go to the third part of this question now.
They are also congruent.
They are also congruent. Very good. Now, can you just tell me verbally which two sides are equal?
Yeah. TF is equal to PQ.
Very good.
And DE.
DE.
No, sorry. EF. EF is equal to RQ.
Very good.
And then and then F is equal to Q.
Angle F.
Yeah, angle F is equal to angle Q.
Very good. So triangle, which triangle is congruent to which triangle? Name them.
Angle D.
Triangle.
Sorry, triangle DEF is
congruent
to triangle PRQ.
Very good, Hiba. Excellent. MashaAllah. Next, fourth one.
They are also congruent.
Very good. Can you tell me which triangle is congruent to which triangle? First, tell me the corresponding parts. Okay, tell me which side is equal to which side, then which angle is equal to which angle, then which side is equal to which side.
P is corresponding to R.
Which one are you talking about? Angle or side?
Angle.
Now, Hiba, when you say angle P, see, it's like this, right? This is P. When you say angle P, you're not making it specific whether you're talking about this angle or this angle or this whole angle. That's why you have to mention it specifically, which angle exactly are you talking about. Okay. So name the angle in the full form. You have to talk about the full name of the angle. Okay.
Okay. So angle P is corresponding to
no
angle.
Full name of the angle. Full name of the angle, please.
What's the full name?
Angle QPR.
Oh yeah, sorry. Angle QPR is corresponding to RPQ.
RPQ.
RQP.
RQP. Which one is angle RQP, Hiba? Angle RQP is the one that is angle Q. Angle RQP is this angle. Look at the diagram. It is this angle. RQP means the middle point is the middle letter is the vertex.
This is confusing.
Okay. Okay, so let's make the diagram here. P, Q, R, S, 30 degrees, 30 degrees, 3.5 centimeters, 3.5 centimeters. Now, first, Hiba, if you're getting confused with the angle, leave that for now. Tell me which two sides are equal first.
PS and QR.
PS. Is it given anywhere that PS is equal to QR?
No, sorry. PQ is equal to SR.
Hiba, see, let's not get confused. Let's see which two triangles are we talking about. Triangle PQR is one triangle, and that is congruent to triangle RSP. Okay, these are the two triangles. Now, can you tell me?
So the red one is PQR.
Yes.
Okay, so it will be PSR.
First tell me which side is equal to which side?
What do you mean by side here?
In these two triangles, the red triangle and the blue triangle, do you have equal sides?
Yes.
Tell me which two sides are equal.
The line.
Name them.
PR.
PR. Okay. 3.5 and 3.5, are they equal or not?
Yeah.
They are equal, right? So in the red triangle, it is PQ is equal to what?
SR.
RS.
Oh yeah, RS.
Very good. Next, so one side SAS we have to do, yes? So
If
SAS side we have done.
If I write SR, will it be wrong?
You tell me. You are saying PQ. PQ. So PQ, and look at this triangle, the blue triangle. Should you be saying RS? Because look, the angle is at R over here. Should you be saying RS or SR?
RS.
Understood?
Yes.
So out of SAS, we have done one side. Now we have to do another side and another angle. So let's leave the angle for now. For the time being, let's move to the side because the angle is a little bit confusing for you. So let's do the side first. What is the other side that is equal in these two triangles? That is given equal. We don't have to assume anything over here.
The P and angle
Not
R.
angle, but say side. Tell me about the side first. The other side, this one. What do we know is already equal?
PQ and RS.
That too we've done. And we have to have another side that is equal, right? Only then we can have SAS congruency criteria.
PS and
PR. How about PR? Do PR is equal to PR?
Yes.
In fact, RP, I should write it like this. And PR and RP, they are both equal. Obviously, it's the same line segment. And they are both part of these two triangles. So that's why we've written it like this. Is it okay?
But how are they equal?
Sorry?
Are they equal because of 30 degrees?
Bacha, any side PR, forget about everything else. Just look at the line segment PR. Forget about the angle, forget about whatever else is there. Look at, one sec. Yeah. Look at this, okay? Just look at this line segment, PR. Do you have any random line segment over here? Is it equal to itself or not?
Yes.
Yes, everything is equal to itself, right? 5 is equal to 5, 10 is equal to 10. So over here it says P, here it says R. So you say PR or you say RP, same thing. So PR is equal to RP. That's why we've written it like. Got it?
Yes.
So now we have gotten two sides. This side done, this side done. Now we need, what do we need? One angle?
Yes.
Yes. And that
It
should be
is.
the included angle. Yes, between the pink side and this 3.5.
So it will be P angle P equal to angle R.
Again, we have to write the full name of this angle, bacha, because angle P could also mean this entire angle. Got it?
Okay.
So that's why we have to make it specific what this 30 degrees that we're talking about, what is its specific name? What can we call it? Can you tell me what is the name of this angle in this triangle, in the red triangle?
QPR.
Very good. So
So
angle QPR is equal to
angle SPR.
SRP.
Oh yeah, sorry, SRP.
Why? Because SRP is this angle, na? See,
This
SRP
angle.
means the starting point is S, vertex is R, ending point is P. Starting point is S, vertex is R, ending point is P. So it is this angle, the 30-degree angle. Getting it?
Yes.
Good. So now can you tell me how will we write which triangle is congruent to which triangle?
Angle P, sorry,
Triangle.
triangle QPR is
Triangle.
QPR.
QPR, very good.
Yes, sorry. Triangle QPR